Hello everybody. So today we are going to be going over elimination. So we have learned how to solve systems of equations by graphing. So we would just graph each of our equations, and then wherever those lines intersected was our solution. And then we just learned about substitution, where we had to solve one of our equations for a variable and then plug that back into our other equation and then solve, and then so on and so forth. So today we are going to be going over elimination. So to start off, we have our steps for how we do elimination. The very first thing we need to do is line up our variables. So remember that we have two equations. So we need to make sure that our x's are lined up, so the x from our first equation is above the x from our second equation. And then the y's from the first are above the y's from the second. And then our numbers that the equations equal are lined up as well. Step 2 is to determine what variable you want to get rid of. I feel like this kind of goes in hand with step 3, so they kind of go together. So when you're doing elimination, you are adding your two equations together. And so whenever you add these together, one of your variables should drop out. That is kind of the whole purpose of it. And so you need to take a look at your equations and try to determine which variable is going to be the easiest one to get rid of, and then go with that. So once you decide which one you want to eliminate, you add the equations together. When you do so, you should end up with just one variable. So x equals or y equals. And then you solve that equation for that variable. Once you get your answer, you then have to plug that back into our original equation and then solve for the other variable. And then we finally have our whole final answer. So let's get into some examples so you can kind of see this process actually working out. So in example 1, we have 2x plus 5y equals 17. And 6x minus 5y equals negative 9. So first thing we needed to make sure we had was that our equations were lined up. So x above x, y above y, which we have. So we can see that. Next, we want to decide which variable we want to eliminate. So in doing so, you need to look at both equations and determine when you add these together, what variable could drop out. Now, in this case, if you look, you notice that our y's, we have a positive 5y on our first equation and a negative 5y on our second equation. So this is actually exactly what we want to have, because when we add those together, those y's will drop out, right? Because a positive 5 plus a negative 5 is just 0. So then our y's go away. So we do 2x plus 6x, which gives us 8x. We already said 5y plus negative 5y is just 0, so it just goes away. And then we have 17 plus negative 9. And we get 8. 17 plus negative 9 is 8. So now we are left with 8x equals 8. And then we have to solve for x. So to do that, we just have to divide both sides by 8. So we get x equals 1. Okay, that is just part of this problem. Remember, now we need to plug that back into one of our equations so that we can solve for y. It does not matter which equation you use, you should get the same answer regardless. I'm just going to pick the top equation of 2x plus 5y equals 17. We know that x is 1, so I'm going to plug that in. So 2 times 1 is 2. And then we just bring everything else down so that 5y and 17 come down. And now we are trying to get y by itself. So we are going to subtract 2 from both sides. So we have 5y equals 15. And finally, our last step, we divide both sides by 5. and we get y equals 3. Remember that your final answer has to be written as a coordinate. Be careful, make sure that you put your x variable first and then your y. So our x was 1, our y was 3. So this is our final answer. All right, on to number 2. Remember that this is a video, so you guys can pause at any time or go back and re-listen if something's not making sense. All right, so we have negative 3x minus 3y equals 9, and 3x minus 4y equals 5. So everything's lined up. It looks nice and pretty there. So now we need to look at eliminating a variable. So always look first and see if you have that same coefficient, that number in front of your variable. Always look for that first. So in this case, if you look at our x's, we have a 3 in front of our x for our first equation and our second equation. And one of those happens to be negative. Well, whenever we are adding these equations together, that's what we're looking for. We are hoping that we have a positive and a negative. So we don't have to do anything special here. We just have to add these two equations together, and one of our variables already eliminates itself. So negative 3x plus 3x is just 0. It goes away. Negative 3y plus negative 4y is negative 7y. And 9 plus 5 is 14. And then we need to get y by itself, so we divide both sides by negative 7. And we get y equals negative 2. Then we need to solve for x. So we just pick one of our top two equations and we plug in. I'm going to use 3x minus 4y equals 5. And then I'm going to plug in that negative 2 for y. So we have 3x. Remember, this is negative 4 times negative 2, which gives us a positive 8. And then we still have that 5. So at this point, we are trying to get x by itself. So we have to subtract 8 from both sides. So we have 3x equals negative 3. And last, we divide both sides by 3 to get x equals negative 1. So then our final answer, we write as negative 1, negative 2 in our parentheses. All right, number 3. We do have quite a few examples to get through. If you feel like you're pretty confident, just keep watching because it gets a little more complicated as always. Okay, so number 3, we have negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. So this one, it's not all nice and pretty for us in the fact that it's already set up for one of our variables to eliminate. So this is where it gets a little tricky. So what you want to do at this point is look at your x and y's, those numbers in front, and determine the greatest common multiple. So our x variable, we have negative 2 and we have 7. So our greatest common multiple between negative 2 and 7 would be 14, right? Now to do that, we would have to multiply negative 2 by 7 and 7 by 2. Okay, so now look at our y's. So we have a 15 and a negative 5. The greatest common multiple between those two would be 15, right? Well, one of those is already 15. We wouldn't have to do anything to that one. We wouldn't have to change anything. But then the 5, we would have to multiply by 3 in order for it to be 15. So that is exactly what we are going to do. We are going to turn that second equation into a negative 15y so that when we add those together, our y's drop out. The way that we do that is we multiply everything in that second equation by 3. Okay, so I'm going to rewrite our top equation. So nothing changed there. I just kept everything the same. And then on the bottom, we do 7x times 3, which gives us 21x. Negative 5y times 3 is negative 15y. And then 17 times 3, which gives us 51. So now we can add these two equations together. Negative 2x plus 21x is 19x. And then positive 15y plus negative 15y, that's just 0, so it just drops out. And then negative 32 plus 51 gives us 19. And then we divide both sides by 19. So we get x equals 1. So now we pick one of our two equations and we plug that x back in. I'm going to choose this second one. 7x minus 5y equals 17. So we plug in our 1 for x. 7 times 1 is 7. Bring down everything else. We subtract 7 from both sides. Remember that that negative 5y is negative, so remember to bring that down with it. And then we divide both sides by negative 5, and we get y equals negative 2. So then our final answer, 1, negative 2 in our parentheses. All right, so at this point, I would have you guys try one on your own, but since I'm not there, I'm just going to go ahead and walk on through it. If you would like to, you can pause this video so that you can try it on your own just to see how you're doing, and then you can watch and see if you got the same answer. So we have negative 5x minus 2y equals 6, and 3x plus 6y equals 6. So I know these aren't lined up nice and neat. The formatting was a little off, but we do have our x's first, our y's second, and then our constant there at the end. So look at your x. We have negative 5 and we have 3. So greatest common multiple would be 15, right? Because 5 times 3 is 15. 3 times 5 is 15. Then our y's, we have negative 2 and we have 6. So greatest common multiple there would be 6, right? Because 2 times 3 is 6, and then 6, of course, is just already there. There is nothing wrong if you decide to eliminate the variable x instead. It's just a little more work to do. So I'm going to stick with just eliminating our y. So to do so, I need to multiply everything up top here by 3. Okay, so negative 5x times 3 is negative 15x. Negative 2y times 3 is negative 6y. And 6 times 3 is 18. And then I'm just going to rewrite that second equation, just bring it all down so it's actually lined up nice and neat. And now we add those equations together. Negative 15x plus 3x is 12x, negative 12x. Negative 6y plus 6y is 0, it drops out. And 18 plus 6 is 24. We need to get x alone, so we divide both sides by negative 12, and we get x to equal negative 2. So now we plug that back into one of our equations. I usually try to pick the equations where there's either smaller numbers or all positive numbers, just so it feels like there's less room for error. So I'm going to go with 3x plus 6y equals 6. And then I'm going to plug in that negative 2 for x. So 3 times negative 2 is negative 6. Bring down everything. We add 6 to both sides. So then we have 6y equals 12. And our last step, we divide both sides by 6 to get y equals 2. So then our final answer is negative 2, 2. All right, so now we get even a little trickier. So it's been kind of nice so far. Either everything's been given to us, on a pretty perfect platter where we just have to add our equations together and a variable automatically eliminates, or we just have to multiply one equation by some number, and then when we add them together, it eliminates. Well, now I'm going to show you that in some cases, that just doesn't work. So for this one, we have 3x plus 2y equals 1 and 4x plus 3y equals negative 2. So if you look at our x's, we have 3 and 4. So greatest common multiple is going to be 12. So to do so, we would have to do 3 times 4 and 4 times 3. And then we look at y. So we have 2 and 3. So again, greatest common multiple there is 6. So we would have to do 2 times 3 and 3 times 2. So no matter what we choose to do here, we are going to have to multiply both equations by a number in order to eliminate. So I'm going to choose y. I want to try and get y to go away. Okay, so keep in mind that right now, our y's are both positive. In order to eliminate a variable, one of those has to be negative. And then we've already decided that our greatest common multiple is 6. So I'm just going to go ahead and multiply this top equation by negative 3. So that's going to make my y a negative 6, right? Because 2 times negative 3 is negative 6. So then that means my bottom equation, I want to have a positive 6. So we are going to multiply by 2 because positive 3 times positive 2 is positive 6. All right, so when we multiply our top equation by negative 3, we get negative 9x minus 6y equals negative 3. And then on the bottom equation, when we multiply by 2, we get 8x plus 6y equals negative 4. All right, now we add those together. Negative 9x plus 8x is just negative x. Those y's, we have a positive 6y and a negative 6y, so they drop out. And then negative 3 plus negative 4 is -7. Be very careful here. We are not done just yet because that x still has that negative out front. So we need to get rid of that negative. Remember, that is just like an imaginary -1. So we just have to divide both sides by that negative to get rid of it. And that gives us x equals a +7. So now we pick one of our original equations. I'm going to choose 3x plus 2y equals 1. And then I'm going to plug that 7 in for x. 3 times 7 is 21 plus 2y equals 1. Subtract 21 from both sides. We get 2y equals -20. And finally, we divide both sides by 2 and get y to equal -10. So final answer is 7, -10. All right. So as always, in all of our different problems that we do, we always have those special cases, correct? So now we are going to look into those special cases. Remember that your possible answers for special cases are infinitely many solutions or no solution. So looking at our next two equations, we have 2x plus 6y equals 18 and x plus 3y equals 9. So you might be able to just look at this and kind of see what's going to happen already. I am going to decide to get rid of my x's. So we have 2x and x. So we need for both of them to be the same. So 2 is going to be the easiest one. And then one of our equations has to have a -2. So I will multiply the bottom by -2. I'm going to rewrite that top equation. And then on the bottom, if we multiply by -2, we get -2x minus 6y equals -18. So you might be looking at this and already noticing some things. So when we add these together, we have 2x plus -2x. Well, those drop out. We have 6y plus -6y. Well, those go away. So that's everything for the left-hand side. We don't have anything left. We just have a big fat 0. And then on the right-hand side, we have 18 plus -18. Well, that also goes away. So we just have 0. So our final answer here is 0 equals 0. That's okay. Remember, 0 is a number, and 0 does equal 0. That's a true statement. So our answer is infinitely many solutions. Remember, you can shorthand this to either IMS, or you can show me that infinity symbol. Both of those, or fully writing it out, are perfectly acceptable. Alrighty, on to number 7. So again, looking at number 7, you can just kind of look at it and see a little bit that it's going to be a special case of ours. So we have -2x plus 5y equals 7, and -2x plus 5y equals 12. So right now, if we add these two equations together, nothing is going to eliminate. But if we multiply one of these equations by -1, then we can get something to eliminate. So I'm going to choose this top equation. I'm going to multiply everything up top by -1. So then we end up with 2x minus 5y equals -7. I'm going to bring down that second equation. And we're going to add everything together. 2x plus negative 2x, whoopsies, goes away. That's just a 0. Negative 5y plus 5y goes away, so we just have 0. And then negative 7 plus 12 is 5. So we end up with this statement of 0 equals 5. Well, that's not true. 0 and 5 are not the same number. So our answer there is no solution. So remember, if you get a true statement, infinitely many solutions. If you get a false statement, no solution. And finally, our last problem. So our last problem is very similar to problem 5, where we have to multiply both equations by a number in order to eliminate something. So if you want to pause the video for a second and try this one on your own, see how you do, and then compare with me, that's great. If not, then just go ahead and keep watching, and we're going to walk through it. So we have 2x minus 3y equals negative 12, and 3x minus 2y equals 2. So in both cases, x and y, the numbers that we have in front are 2 and 3, right? So greatest common multiple that we have for all of our numbers involved is 6. Notice that both of our x values are positive and both of our y values are negative. So we just kind of need to make a decision going into this plan of attack. Do we want to get rid of x or do we want to get rid of y first? It does not matter. You should get the same answer regardless. But I'm going to say let's get rid of x. Okay, so if I want to get rid of x, we know that one of these equations has to have a negative 6x. So I'm just going to go ahead and get that knocked out on this first equation. So I'm going to multiply everything by negative 3. So then that means on my second equation, I will multiply everything by positive 2. So then 2x times negative 3, negative 6x. Negative 3y times negative 3, positive 9y. And negative 12 times negative 3 is positive 36. In our second equation, 3x times 2, positive 6x. Negative 2y times 2, negative 4y. And 2 times 2 is 4. We add our two equations together, negative 6x plus positive 6x, that goes away. 9y plus negative 4y is positive 5y. And then 36 plus 4 is 40. To get y by itself, we have to divide both sides by 5. And we end up with y equaling 8. So now we take one of our equations, plug 8 back in. I'm going to pick this second equation just because that end constant is positive, but again, doesn't matter which one you pick. Remember, again, just a friendly reminder, plug into the right variable, otherwise you're going to mess up all your answers. We bring down that 3x, negative 2 times 8 is negative 16. And then we're trying to get x alone, so we add 16 to both sides. So we get 3x equals 18. And last step, divide both sides by 3, and we get x equals 6. So final answer, 6, 8. All right, so that is the lesson for today. You guys just have homework today. If you decided that you finished the notes early enough and you were ready to get onto the homework, it is posted. It's digital, or you can get a hard copy from your sub or Miss Farwig. And that will be due in class on, I see you guys, on Friday. So get to work on that. I will also have these notes just posted in Blackbaud as well. So if you just want to go through and see the examples as opposed to watching the video, you can see that as well. Email me if you guys have any questions.